This is probably going to be a short one today. Started pretty late in the morning, but I have exciting news for those that are new to the stream. I am making a game engine in C++ and Vulkan, and I've been doing so for a long time. We're finally, like 5 years or so. For a long time I'm working with my husband, but now he's dropped off for a while indefinitely, and now it is just me. So for the last month, about the month of June, I've been working on getting baked cloth physics simulations into the game engine. So if you think about someone twirling with a long skirt, all the folds of the cloth, I want to be able to represent that without doing live cloth physics simulations. So it's been a really long journey, but I'm very happy to say that we did it. So I'm not done yet, but I have some cloth physics, and it's very exciting. I'm going to resize. I'm trying a new stream format, but let me resize this so that it shows up a little bit easier. Go. All right. So we did it. I felt so good yesterday when I saw this. Oh, and then we have our plane too. Let's just look at its beauty for a while. Oh my gosh, you guys, this is such a good day. This has taken me the entire month of June to get going, and I'm mostly done. There's a lot of cleanup. I have some tests to do, and I still don't have the last actual coding task is to get the skeletal animator component, which I've already templated and made ready to be reusable by another type of animation, a la shape keys. I just have to actually integrate that so that you have state transitions and such. But I'm so happy. So let's see. I don't remember where we left off, but I can give a little demo of how this stuff all plays together. So here's the workflow. I would go into Blender, and or any 3D modeling software, and Blender or any 3D modeling software here, and you would make some kind of simulation. And the wonderful thing about shape keys is they're incredibly generic and reusable. So with skeletal animation, you have to have an armature, or at least a bone, and the way that skeletal animation works is your graphics engine will interpolate between the positions of the bones. Oh, I just lost my train of thought. So say you have a bunch of vertices here, they're all going to be influenced by the 4 nearest bones to them, or the 4 bones that you've weight painted onto them. So then, depending on the weights of the bones on that vertex, you're going to apply the transform of the bone onto the final transform of the vertex. So that's skeletal animation, and it's great, but the drawback is that what if you don't have bones? So a lot of people, for cloth physics, or maybe not a lot of people, I've seen a couple people, will actually put bones on each of the vertices and then simulate the cloth physics, and then now you have an animation because now you have your bones. But I didn't want to do that. It seemed tedious, so instead, in the true spirit of indie game development, I decided to spend a month and counting implementing a system by which I would not have to rig every vertex of a cloth or physics simulation. So anyway, what I was saying was the very nice part of shape keys is they're very general and repurposable, because all they are is just a snapshot of the position of every vertex in a mesh. And if you think about that, that's really reusable. So I don't need bones. I could have bones and where okay, so say if I have an armature, if I wanted to, I could position my armature however I want to, and then just take shape key animations of each of the positions. Then I wouldn't need bones at all. But I'm assuming, I haven't really done much testing, but based on what I've known and learned through implementing this, that would be much less efficient than skeletal animation. But you can literally animate anything you want to if it involves vertices and positions. Okay, that was a little bit of a tangent, but what I was going to do was show you the workflow and how it works in the engine, what I've done in the month of June. So say I come in here into my 3D modeling software and I simulate a flag with a wind force somewhere around here blowing this way. Then I have my clip and I convert it to shape keys either through this CTK cloth to keys add-on that I used for this, or you can just manually create your shape keys, which I did for the plane and the cube. Then I'm gonna go into File, Export as GLTF, and I'm doing binary GLB. Export it somewhere. Then I take that and I copy it and paste it into the game dev, or the game engine's assets folder. Then I will go and I'll run our converter tool. And actually, one step I missed. So now let's say I have a mesh in my assets folder. I'll show you where that lives. Okay. So, export something out of Blender, go into the source folder for the game, go into the samples folder, assets, raw, model, and I paste it in here. So I have my flag in GLB format. Then I'm going to go into our manifest file. Hold on, coffee break. Our manifest file, which is just JSON that lists all of our different type of assets, and I've added a shape key animation asset type here. So you can, with some of our asset types, they have sub resources. So if you think of Blender really being a scene format, move that over a little bit. Blender can create scenes, doesn't necessarily just make a single mesh. So a scene can have a mesh or one or more meshes, and it can also have one or more files of very many different kinds. But in our case, a scene can have one or more shape keys animations. So we have a sub-resource format here. So I can put a comma here and say things like oh no, that's not right, like this. So I could have, let's say I have two shape key animations for the flag, I could have flag blow, and then that would have to align with the name of the shape key animation clip. So you'll see that I've added one for waving the flag, and then I can come in here and run the conversion tool. And so that was done probably close to first. There's a lot of cleanup that I have to do here, but this will do is it'll use ASAMP to come into the GLTF file, the GLB file, and parse out this concept of a morph animation, or an anim mesh is what they call it. So then we parse all of the data out of the actual GLTF file and into a format that we like, that we're happy with. And that format looks like this. And I am so proud of this. I have mentioned it a couple times on stream, but this is the first time where I've encoded non-image data into a texture file. And I feel like I'm officially a graphics programmer for having done so. I finally got my stripes. Just feels so cool to do. So the format is something like it's a texture float, so it's R32S float is the format, but then the actual data layout is like so shape key animations are a copy, so each frame of shape key animation is called a shape key, kind of. We're simplifying here. So a shape key is just a collection of vertex offsets for every vertex in the mesh. So the way that we've represented that here is, let's say you have a plane with 4 vertices. Our float format, the first row is going to be X, which is one float, X, Y, Z, X, Y, Z, and X, Y. I'm going to zoom up a little bit. Hope that wasn't too small this entire time. My bad. Okay, so we were talking about the underlying data structure that I got to fit into this. Oops. Maybe that's too big now. We'll see. Okay. So each float, or each vertex, will have 3 floats, so an X, Y, and a Z offset. So this would be one shape key. So if we have, in this example, each of these keys, each of these yellow things are a shape key. And we have something like 25 of them in this flag. So we would have then 25, if there were 4 vertices, which there are many more in a flag, but we'd have, say, a plane with 25 shape keys, we'd have 25 lines of data here. And that is our texture format, and it represents the actual animation data. So that's what this is. Then we have a duration in seconds of the animation, and a total number of shape keys, which would be the number of rows in the image. So we parse that out of the GLTF and into an asset format, and then that goes to live. Whoops. That goes to live in the shape key animation NCA folder in that same assets directory. And the conversion tool, when you run this tool, that does all of that. So then the next thing I did, and this isn't in chronological order, this is in like functional in linear order as far chronological. It's not chronological order as far as the order in which I developed it, but it's chronological in the order of the workflow that it takes as it goes through the system now. So then the next thing you do after you've generated your asset file in NCA format is you're going to run this prefab generator. And I wish I could take credit for this, but this was all my husband. So what this does is it takes a manifest and takes the assets in the manifest, you give it a namespace, and you give it an output directory, and it will generate basically an object model, the C++ object model for every one of the assets, which is cool. Because then, now that we've generated the asset, or the object model for the asset, if we want to go and use our cube, it's just already right here. Or our flag, it's already right here. Okay, so what have we done? We've created a shape key in Blender. We've exported it as a GLTF. We've imported it from a GLTF into an NCA. And then we've run the code generation. So we have C++ that exists as an object model for the asset. Now, in our test scene, so this is the graphics test. Oops. This is the graphics test scene that I just do all of my graphics experiments. If we want to see our guy in there, we need to create an entity and put it wherever we want to. So position, give it a rotation, give it a scale. I'm gonna get rid of the plane for now. Make this guy bigger too. Oh, not that much bigger. And then you in place into the ECS container, you in place a static mesh, which is our static mesh or skin mesh. Static mesh is meshes that don't have skeletal animation, and then skin meshes are meshes that do. And both of those support shape key animation. So you pass it the name of the entity that you want to append the component onto. Then you give it the object model for the mesh, the handle for the object model for the mesh, and then the handle for the material. And now this is new. I added the handle for the shape key animation. So that is all the system needs in the back end to go out and find the asset ID. So now let's talk about the representation on the GPU for a minute, because we missed an important step. So we have this reload prefabs call, and what this prefabs reloader call does is it goes into the generated assets folder and or the file, and it finds all of the shape key animations that we just created object models for, and it will go out and load the NCA into GPU memory. So let's look at that code for a little bit. Okay, so this goes from NCA file into GPU memory. So we have a asset manager that I just made, and it will call the prefab load, will call this load, given the paths that have been encoded into the object model, which is all code gen, thanks to my husband, which is so cool. And we'll iterate through each of the paths, and we will say, and someone asked, why do we use std string path instead of std file system path? And the answer is we just haven't updated it after learning about file system paths. This is really old. This is one of the first things we did in the engine years ago. Okay, so we iterate through each of the paths, and then we call this import call, and that's going to import the animation into the out of the NCA serialization, and I'm going to deserialize it into that shape key animation. And then I create a struct called a texture with an ID, which is that underlying float texture format, and an ID, which is just a F1NVA hash, or whatever that is. Calder, my husband wrote that. So now we have we've gone from GLTF into NCA. Now we've gone back from NCA into kind of a just usable data format, which is that asset format that I was showing you originally. So now we have a vector of those, and we're going to then call a signal, which is essentially raise an event, that emits this update event data, and it contains our span of our animation structs, and then that is going to get picked up by our asset dispatcher right here. So when that event is raised, it comes into here, and this is our GPU stuff. So this class takes and handles to our the CPU side of our buffers. So this has just either a ref or a pointer. Actually, I think it's all refs here. Reference to our buffers and texture array classes, and those live in a different place. They're managed elsewhere, but asset dispatch has a handle to them. When the event is raised, we go and we find the underlying, where is it? We have a texture array for the shape key animations, and then we also have a structured buffer for the metadata. So we come in here on event load, and we will come and upload the textures into our texture array, and this is at the point at which it gets uploaded to the GPU. And then we also have a metadata buffer, and I can show you what's in there. So now we have the buffer and the texture array have been added to the GPU, and this buffer just tracks, so every mesh has an instance concept. That buffer already lives on the GPU, so I'll show you, make it a little bit less confusing. So this data lives in a structured buffer on the GPU, so every mesh knows about its current instance. So it has this shape key metadata index, which is an instance or an index into this new structured buffer, which is an array of buffers or an array of structs. And this guy just holds all the metadata that we need at vertex shader time to do all of our GPU calculations for shape keys. So it holds another index into the texture array, and this tells us what animation are we actually looking at in our texture array. And then it tells us how long is the animation, so we can do our linear interpolating. And it tells us how many rows are in that texture file, which we just need for lerping. So then let's look at RenderDoc here. Let's try to find a nice calm background. Okay. I don't know if I like that or not. Maybe RenderDoc will not. Oh, yeah, that. I don't know. I'm trying to find. I like this new format, but maybe let me know if you like it or not. I'm not sure if I'll keep it, because I want you to be able to focus on the work that I'm doing, but have it be more zoomed in, and also have me in the room in the background, so it feels like there's a place where people can go rather than just a tiny little picture and then the giant screen where it's hard to focus on exactly what I'm looking at. But we'll see if people like it or not. Okay, so this is RenderDoc. If you have never used it and you do anything graphics related, you should use it. It's free. It's a really cool tool, and it allows you just to investigate many different aspects of a rendered frame. So I'm capturing this frame, and what we're going to do is just look at the representation of the data on the GPU. So this is kind of a mess because I need I need to consolidate the amount of times I'm calling my vertex shader, because I'm rendering the same scene many different times right now. But that's not what this talk is about. Okay, this is my normals pass. We're looking for, oops, let's go over here. I want, I need a good dark thing to go on this side. Okay. There we go. That's nice. So this is the basic tune pass is what I call it. It's just the pixel shader for all of our colors. That's done here. And what we were looking at is, let's first go to the mesh viewer, because I did a lot of debugging. Oh. Which one are we looking at? We're looking at our flag, which I thought was you. Oh, it's 6516. Okay. So then we open up our mesh viewer, and this actually looks, it allows you to debug the vertex shader, which is really cool. But if you see here, we can go to pipeline state and look at all of the data on the GPU that I was talking about. So this is a static mesh. So this is the static mesh instance buffer. And ours is, I think it's this guy. And you can see the shape key metadata index that has been set in the interface right here. So I told in the game, this represents the game, by the way. So if a game dev were coming in here and they wanted to create a new shape key, they would pass the asset ID of the shape key animation they want to use. So we chose flag. That gets translated right into a metadata index because the flag texture array has already been loaded up, and this just points to the structured buffer indexing of the structured buffer that holds the pointer into the texture array. So number 2, then if we look in here, this is that metadata buffer. So we have our number of shape keys, it's 25 for the flag, the duration in seconds is 10, the shape key animation index is 3. So this is what the GPU is using in the vertex shader to do all of its calculations. Then if we go into here, the last piece of this puzzle is our actual animation data. And this is so cool. So this is the texture for the plane, if I remember correctly. The plane has 3 shape keys, and a total of 12. I think it was 12 or 4 vertices, so there's going to be 12 pixels here. 1 pixel per float and 3 floats per vertex. So a total of 36 pixels here, and you can see that it's a 12 long and 3 down. And then with the, let's look at the vertex shader now. This was a really, really fun exercise. This whole thing was very fun. Okay, tune. So this needs to be cleaned up a little bit, but a lot. Oh, hold on. I gotta keep looking to see if my little tiny window is sufficient here. Okay, so this is our vertex shader for the static meshes. You can see we have a handle to our array of textures, and then we have our sampler, and then this is our shape key texture data. Then we have our handle to our structured buffer of metadata, and then our transforms and static instances. This is the one that has so this struct has an index into this one, and this one has an index into this one. So we come in here and we say, get the metadata index, the index into this one, out of this one. And if it's a valid one, meaning it's not uint max, then get the metadata struct. Then what we do is we take the current time in seconds, and we do a mod operation with the duration in seconds. So if a float mod, so if the duration in seconds is 6.5 and the current time is 4 seconds, then we're going to get 2.5 back. So the wrapped time can never exceed the duration in seconds. Then what we do is we divide that by the duration in seconds to normalize it. And then we say, okay, take that normalized time and then multiply it by the number of shape keys minus 1. So that's like, say it's like 0.81 or something. That means that we're going to be 80% of the way through our total shape keys vector, meaning 80% of the way through the rows of the image. So we would look at, if there was 10 shape keys in the image, we would be at in between, I can't remember if I said 80 or 81, but we'd be in between 8 and 9. So that's where we take the floor to get 8, and then we take the some fancy math here to get 9, and then we just get the remainder portion there as our lerp. So let's be a little bit more technical here. So let's say that this is 8, and then if we were like 8.5, 8.7, let's say, we would get 8, and then we would get 9, and then this would be 0.7. And because we would be 0.7% or 70% in between the 8th and 9th frame. So then with our indices here, we also have to do something fancy, because I'll explain this line of code next. I'm using indexed drawing, so if we look into our mesh, what we need, so if you remember, a shape key is a position offset for every vertex in the mesh. So what we're going to be doing in the end in the shader is adding that offset to the mesh's local position. And in order to do that, we need to know what vertex we currently are executing in the vertex shader, and then find that same vertex. And we're not going to do any lookups. We just have to pray that they're in the right order. But we still have to know. We don't have a map, an association. We're just relying on the fact that they're the same, because we know that ASMP exports them in the same order. But anyway, we wouldn't have to do anything if SV vertex ID here. We wouldn't have to do anything if this semantic was 0 through n, where n is the number of vertices. But because I'm doing index drawing, it's actually, we're starting with the index, which is 47,306, and through 48,569 in the flags case. which means that when we're going to index into our shape key texture to get the set of 3 vertices that we want to add, we don't want to index into the 47,000th set of 3 because there's not going to be 47,000 vertices here. That's the mesh offset, or the vertex offset in the mesh buffer, index offset into the mesh buffer. So what we have to do is we needed to add that the position of the first vertex in the index buffer to the static mesh instances. So I did that. I can show you that here. That's a lot of words, but essentially we just need to know what position into the index buffer is your first index for the mesh, because we store all the meshes contiguously. So we pass that in as the base vertex ID. So then our texel chords, actually we pass it in as our current vertex ID 47,900 minus whatever the offset is. So it'd be 47,900 here, and then so that'd be 0. So then we take 0 and we multiply it by 3, and then that gives us our, so that's the x, and then the, so if you think about x being the vertices and the shape key index, y being what shape key are you looking at, what keyframe essentially are you looking at in the animation. So we do that for the low because we want to get the, we're going to interpolate between the low and the high, the 8 and the 9 to get our 87%. So we get our 8 here, and we get our position offset for the 8th keyframe in X, Y, and Z. Then we get our position offset for the 9th keyframe, and then we lerp using that 70% between them, and that gives us a lerped position offset for the current exact time. And then we add it to the position, and that is it. So I have a lot of cleanup to do. There's comments everywhere. It's a comment graveyard right now. And the last thing I need to do is we already have an animation controller. And the animation controller whoa, get out of here, plane. The animation controller allows us to have a state machine between animation. So maybe if I hit spacebar, we want the flag to unfurl or furl. I don't think I've ever used furl as a verb, but or we want it to bounce up and down and have the physics react realistically based on our baked animation. So we already have the work for the animation controller because almost 100% of it is reusable. So if I'm pressing the forward key, this guy walks. If I press spacebar, he jumps. Right, he turns right, etc. Thanks, Mixamo, for your animations, because I can't do it. So we just need to reuse that class for this guy. It'll be a little bit different because this guy I'll use skeletal animations almost entirely CPU side, and then shape key animations are all GPU. So there's a little bit of nuance there. It probably will take me a day or two. And then lots and lots of unit tests and cleanup, and we are done. So this has been a really exciting exercise. I'm going to move on now. I want to learn how to make pulp art, which is a total 180, but I'm really into, for the game that I'm working on, really excited about vintage fantasy paperbacks from the like 60s, 70s, and 80s, and I want to learn how to make that, to recreate that kind of painting. So I'll be working on that on stream for a while once I get shape keys finished, but thanks for the journey, and I'll have a cleanup stream here maybe, or maybe I'll just do it offline. It won't be very exciting, who knows. But yeah, for those that have been following along, thanks. And I don't know exactly what I'm going to pick to tackle next. I really need to help lighting. Lighting looks so bad right now. The shadows look really bad. These are point shadows, and right now I'm only using a 512 by 512 texture size, so they're pretty granular, but they don't look great. But the single direction shadows, like spotlights and directional lights, look just terrible right now. So I'll probably pick that, either do baked lighting or just, I don't know that I'm going to work on cascaded shadow maps. I should, but I just have too much to do when it comes to actually working on the game itself. But I'm sure I'll be doing something engine related here soon. But we'll be spending the next short while on streaming some art while I learn how to paint like in that pulp style. Okay, well that's a short one today. Just a demo of Shape Keys. We did it. Very exciting. Thanks for following along. See ya.